Have you ever noticed how things tend to become messier over time? Your room, for example, doesn't magically clean itself. This tendency towards disorder is what scientists call entropy. Entropy is a fundamental concept in physics. It's all about how much disorder or randomness exists within a system. The more entropy a system has, the more disordered it is. Imagine a perfectly arranged deck of cards. That's low entropy, very organized. Now shuffle the deck. The cards are all mixed up. That's higher entropy, more disorder. The second law of thermodynamics states that entropy always increases in an isolated system. Over time, everything in the universe tends to move from order to disorder. This might sound a bit depressing, but don't worry, the universe has a few tricks up its sleeve. Think about a cup of hot coffee left on the table. It cools down, right? The heat energy spreads out, becoming less concentrated. This is entropy in action. The coffee and the surrounding air are moving towards a state of equilibrium. Now you might be thinking, if entropy always increases, then shouldn't the universe be a completely chaotic mess? Well, here's where things get interesting. Nature loves cycles. Take the water cycle, for example. Water evaporates from the oceans, forming clouds. These clouds then release rain, which flows back into the oceans, completing the cycle. This continuous process demonstrates that what seems like a one-way journey can actually be part of a larger cycle. The water cycle is just one of many examples of cyclical processes in nature. The day turns into night, which turns back into day. We experience seasons changing throughout the year. Even life itself follows a cycle of birth, growth, and death. Black holes, those enigmatic cosmic objects, are often seen as the ultimate representation of entropy. They are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. Black holes form when massive stars collapse at the end of their lives. Anything that crosses a black hole's event horizon is thought to be lost forever, swallowed by its immense gravity. This process seems to fit with the idea of entropy always increasing, with matter and energy disappearing into the abyss. However, even black holes might not be exempt from the cyclical nature of the universe. In the 1970s, physicist Stephen Hawking made a groundbreaking discovery. He proposed that black holes aren't completely black after all. Hawking showed that black holes actually emit a faint radiation due to quantum effects near their event horizon. This radiation, known as Hawking radiation, carries away energy from the black hole. Over incredibly long periods, Hawking radiation can cause a black hole to evaporate entirely. But where does all that matter and energy go when a black hole evaporates? One intriguing possibility is that it returns to its most fundamental form, quantum fields. These fields are the underlying fabric of the universe. They are the realm of pure energy and potential. If black holes do indeed return matter and energy to the quantum realm, it would suggest a remarkable cosmic circle. The ultimate endpoint of entropy, the black hole, could be the starting point for the creation of new particles and energy. This cosmic circle could be a fundamental principle of the universe, a continuous dance of creation and destruction, order and disorder. It's a mind-blowing concept, and while we don't have all the answers yet, it's a reminder that the universe is full of surprises.